Առաջին անգամ մեր podcast-ը այսօր վարելու եմ անգլերեն լեզվով.
We say that the first human mission for Mars, the first human robotic mission, is going to happen in the next 20 to 30 years.
How you decided to pursue a career in astronomy, astrophysics, astrobiology.
Mars right now is maybe the only place or the most promising place in the solar systems where we can look for traces of life.
What's the most exciting thing about your, not the job, but the mission, because it's not a job?
Many of the things we see in the movie are quite likely to be possible.
Which country or which government or organization will be behind the first Mars expedition?
Armenia does not have oil, significant portions. It's not there's any ores that can be deployed. So your natural resource are your brains.
Successfully lands on Mars, there will be a movie and it will feature you. Ողջույն բոլորին, ես Լուիզան եմ Ստաֆեմից, բարի գալուստ Beyond Podcast։ Ցանկանում եմ սիրով շնորհակալություն հայտնել Onyx ընկերությանը մեր այս էպիզոդին որպես գործընկեր միանալու համար։ Մոտիվացված լինելով Հայաստանում դրական փոփոխություններ խթանելու գաղափարով Onyx-ը մի շարք նորարարությունների հեղինակն է։ Իդեպ Onyx ընկերությունը աջակցում է տարբեր կրթական ծրագրերի, իսկ վերջերս հանդես է եկել իր սեփական կրթական նախաձեռնությամբ Սերվիս ակադեմիայով, որի նպատակն է Հայաստանում նպաստել գրագետ սպասարկման մասնագետների թվի աճին։ Առաջին անգամ մեր podcast-ը այսօր վարելու եմ անգլերեն լեզվով, իհարկե ունենալու ենք հայերեն ենթագրեր, իսկ ինչու անգլերեն կիմանաք շատ շուտով։ Սիրով հիմա կներկայացնեմ մեր հյուրին, բայց արդեն անգլերեն լեզվով։ So I'm glad and happy to introduce you to my very special guest today, Dr. Gernot Grömer, who is the director of Austrian Space Forum and the first Austrian analog astronaut. Welcome to Beyond Podcast, Dr. Grömer.
Good morning, and I'm very excited to be here.
Yeah, and that's a great honor for me to host a scientist, such a great achieved person and professional like you.
Well, thanks.
And also I'll share with our audience that Dr. Grömer is in Armenia in the scope of WCIT and TEDx Yerevan, and special thanks to my dear friend Christine Sargsyan from TEDx Yerevan, who arranged and who made this meeting and this podcast routing possible. Welcome to Armenia and welcome to Beyond Podcast, Dr.
Thank you. It's great to be here.
Okay, so we are going to talk a lot about space today, about analog astronomy and all things space, as I say that. But the most important part is where you started. So we almost always start our Beyond Podcast episode with this question: how you decided to pursue a career in astronomy, astrophysics, astrobiology. What was the motivation? Who helped you choose this profession? So let's go.
Well, I think there are basically two ways how you get into the space field. One is science fiction, the other one is amateur astronomy. In my case, it was both, basically. So I think I caught the bug when my parents would give me a little binocular for my 14th birthday. And I realized that, oh my God, when you're just not looking at the neighbors' windows, but up there is magic. There are rules up there. There is an eternity up there. And that really infected me in a way. And then realized after having my first amateur telescope or so, if you want to work with the big tools, the big telescopes, and maybe even getting paid for that, then you have to study astrophysics. And that's exactly what I did. And that career took a little bit of a turn after I had many years of really fruitful and productive astrophysics when I read about an announcement of the Mars Society in the United States, paraphrasing an ad from the early 20th century from Sir Ernest Shackleton, who would go to the endurance expedition to Antarctica, and it said, and that particular ad says, "Hard work, no pay, eternal glory."
Oh.
And they were looking for analog astronauts for the Mars Desert Research Station that was back in 2002. And there were many applicants, roughly 400 people. And
How many?
400.
Wow.
And so I was very lucky to be the only European in that crew as a health and safety officer, because I also had a medical background a little bit. And so that brought me to the field. And, it's like Leonardo da Vinci said in the famous quote that once you've tasted flight, you always want to go back again.
Yeah.
And it's the same here. It's not an addiction, but I have a favor for Mars-like deserts. I have a favor for pushing a little bit the edges and pushing the boundaries a little bit. And if I go home after my day in the office in the laboratory and say, today I've learned something new. Now I know something nobody knew the day before. I call it a successful day.
Great. And as I introduced you as the first Austrian analog astronaut, what does this term mean? So
That's a good question. So no digital astronauts, only analog. So it's basically, it means in analogy to a mission that is yet to come. We say that the first human mission for Mars, the first human robotic mission, is going to happen in the next 20 to 30 years. And we also know it's a tremendously complex and dangerous mission, of course. So we need to practice for that. We need to develop the materials, the workflows, the decision-making hierarchies, all those things. It is much more complex than we saw during the Apollo lunar missions. And so we call this entire branch, it's quite a new field in science since but roughly 20 years or so.
20,
roughly.
Very young.
Exactly. Where we say we need to test before flight as much as we can in analogy to the actual mission. And that's why it's called analog science, analog research, and we're called analog astronauts. So we're not flying, but we are starting at the point where we are already on Mars. So yes, we get to work with spacesuits. Yes, we get to work with some fancy technologies. And also live through the experience. I always say that you've only been truly to a place where you have been with your feet.
Great. And why Mars?
Why Mars?
You are so fascinated with Mars specifically?
Mars right now is maybe the only place or the most promising place in the solar systems where we can look for traces of life. It is, compared to the other planets, still one of the more Earth-like ones. We know, although it's a cold, barren, dry desert right now, it was not like this all the time. We know Mars had a liquid phase when we had oceans on the surface 3.5 billion years ago. Mars had about 4 to 5 times the amount of time liquid water on the surface than it took on Earth for life to spawn. And so it is a question we can address for the first time. We are the first generation after 30,000 generations. That's the age of our species.
30,000.
That's how long we've been on this planet, so to say, as a species. We're the first generation that has a technical means to go there and have a look. And I want to sit in my armchair when I'm retired, watch the first actual mission and say, I designed that screw 30 years ago. So it feels like being part of a big adventure. We are one little wheel in a much larger team of people who have a passion. Mars is in reach. It has a scientific promise, and yet probably even more wonders to discover that we haven't thought about yet. And to some extent, I claim, at least for people in my field, Mars is in us as well a little bit.
Wow, yeah. So you said that 24 to 30 years, in 24 to 30 years, there will be a real...
The first robotic mission to Mars.
Mission to Mars. So the crew, the person leading this mission and the crew, they are actually born already. You mentioned that several times.
Indeed, absolutely, yes. So if we say those astronauts will be like around 40 years, or rather a little bit on the experience side. The crew exists already, and they might be just going to elementary school in Beijing or New York or in Yerevan. Who knows? And so all the work I'm doing in my daily life is for exactly that crew. I don't know them, but I wish them all the best, and I do everything that they have a scientifically productive and safe mission so that they have a good chance of returning again. I'm not a big fan of one-way missions yet.
Yeah. No one is.
No one is yet.
Dr. Grömer, so this like 24 to 30 years, is this your predictions, or this has more like research? And
Yes.
so how this time frame is calculated?
Yes, that's a very good question. It is kind of a consensus in the community. So it's also something I concur, because I know how long the lead times are for constructing complex hardware, and you would need precursor missions or so. It might seem like an eternity to wait for another 30 years or so. But if you understand the complexity of such a mission, that's the day after tomorrow for me. And so we're already not behind, but we are just in plan, just on track, so to say. And it's not only about the technology of building a big rocket ship to go to Mars. It's about the space, it's about habitats, it's about the science you're going to do. It's about how you communicate. So there are probably 1,000 ways to die on Mars. And analog research helps us to understand 800 of those.
Wow.
There still will be a residual risk. No doubt, we're talking about the most ambitious journey we've ever undertaken as a society. Sure. And the crew will have to understand that there is a chance that they might not return. When we do everything we can to make it as safe as possible, but in the back of your hand, you have to understand that if you're sitting on top of a spacecraft that consists of at least 1 million parts, and all of them being built by the cheapest bidder, and if you're not nervous back then, you don't fully understand the situation.
Yeah, I agree. I fully agree with you. Of course, being an analog astronaut and just being in astronomy and astrophysics, astrobiology, these verticals, this is so exciting all the time, new discoveries, and seeing this big picture of one day being landing on Mars. But out of all this, what's the most exciting thing about your, not the job, but the mission, because it's not a job, it's a mission.
Yes, it's
actually.
a calling, yes.
It's a calling and it's a mission.
There are many dimensions to this. I think this notion of that Mars is within reach and within the grasp of our fingertips is something exciting. I know a little bit about Mars, obviously, and so when I close my eyes, I can almost imagine standing there and feeling the winds of Mars, tasting the saltiness of the sand. Metaphorical, you wouldn't do this in real life, of course, yeah. But this being imaginative of this very moment when we, for the first time, humans break the silence on a world that has been silent for 4.6 billion years. And then this magic moment that you look back at sunset and see all the stars popping up, the same stars like you see from Earth, of course, with one difference, and that is you don't see Mars in the sky because you're standing on it, but you see the Earth.
That's...
And having this little bluish little point in the night sky, and understanding that this is the place we came from, reflecting on how many rivers we had to cross, how many mountains to climb, how many wars to endure, what amount of beauty, ingenuity, innovation was necessary to enable us to stand there as a mankind. I think this will be almost overwhelming for a human, and this is the reason why I do my work.
Excellent and terrific. So just a quick interim question: which movie, if there is one, your favorite, the ones that are about space and
there are many out there.
Different missions.
One particular I like quite nicely is The Martian with Matt Damon. And the reason is it's based on a book, actually. And the book is based on an online discussion that went on for several years. So they really had botanists, spacecraft engineers really working on that. So it's surprisingly plausible, let's put it this way, with a few artistic liberties, but it's plausible. And so I think many of the things we see in the movie are quite likely to be possible. Yeah, let's put it. That's how a good movie is, that it's believable.
I watched the movie.
Exactly. The only thing that bothers me a little bit is, I don't know if you know the movie with The Martian.
Yeah, I watched it. Yeah.
Is that this pathological resilience of the protagonist that he says, let's science the shit out of this throughout the entire movie. I think having somebody in the crew who has such an enormous amount of resilience is a little bit pathological and creepy. But otherwise, technically, you really have to look with a magnifying glass to see mistakes.
My favorite is Interstellar.
Oh, yeah, that's a beautiful one as well.
Yeah, in fact, the movie I watched like 5 times.
Oh, really? Did you know they even got some scientific publications out of it?
No,
because when they look into this black hole simulation, this beautiful, magnificent cinemascopic visual, they had to like render that, of course, and so they put on some people from the black hole research community, like Kip Thorne. And they would do some real calculations, and that went to the movie. But they said, well, this is someone's science. We put in this. Let's make a paper out of it. And they got a peer-reviewed publication out of this.
Yeah, no, I didn't know, but I know that the second movie is coming. So I'm very excited and waiting for it. Yeah, just let's get back to scientific part. So let's talk about the mission behind founding the Austrian Space Forum. What does it do? So you elaborated on, supporting scientifically and on experimental basis for the future crew to land on the Mars, the mission on the Mars. But just about the Space Forum.
Yes. So we are a research entity in Austria with 250 people from more than 20 nations. So the connotation of calling ourselves the Austrian Space Forum is only historical. So I always say the official working language in our organization is BE, broken English. And Austria does not have a large space agency like DLR or CNES or NASA or so. So we are basically covering the work for analog research. We're covering the work for, to some extent, with human spaceflight. And of course, not only us, but this is also in the framework of the European Space Agency. And this has been around for 25 years now. We are celebrating this year 25 years of existence. And we are working on analog research, but we also, we flew 2 satellites recently that are working on space debris detection. And we're doing a lot of education outreach. So I also got universities, and we have a lot of people who are teaching in our communities. And so it is a forum where people with a dedication and passion come together that is outstanding. It's really, it's always all about the people, but feeling that inner glow and this commitment to pull on the same side of the rope is outstanding and so much inspiring. I'm humbled every day when I work with people who are really top in their field, but still are people where you want to go for an after-work beer afterwards. So it's this mixture that tells me it's serious science, it's hard work, yes, and you have to go for, you have to acquire funding, and you have to push through obstacles, of course, all the time. But at the same time, you get a sneak preview of the future. And in which privileged situation am I to work in such a thing that this is not a high-tech game in any way, but it's the real thing. And that is a strong driver. The salary is not the primary motivation here. And that's something when we see young people entering the field as well, that there's such a drive, and they really, when they come to us, especially like even school children, when they say, well, why haven't we been on Mars yet? What is stopping us so far? I'm sorry, we're working on it. It's really complex.
The work in progress.
Yeah, work in progress.
Yeah. So, Dr. Grömer, space, there is not a stereotype, but just a perception that space belongs to governments. But there are companies disrupting this, commercial companies. So, can we talk about the benefits that space can bring? Utilizing, if I can say so, the technologies can bring competitive edge not only to governments, to countries, but also to companies.
Yes. I rarely use the word transformation or being disruptive, but that's exactly what we see in the field now. To give an example, we are right now counting about 8,000 active satellites in low Earth orbit. 8,000, yes, active. More than half of those 8,000 belong to a single company, SpaceX, which is providing Starlink. That means one single American company owns and operates more satellites than all governments, all other constellations combined. And
even
this
the
is
US.
Even the US, even China, even Russia, everybody combined has less satellites than this sole company alone. There's a Euroconsult study that by the year 2030, we're talking about 75,000 satellites. It's getting
And
denser
again,
and
with
crowded.
SpaceX's domination, what do you think?
We'll see about that. There are other mega constellations coming up with where they're thinking about launching in batches of hundreds of satellites. We're talking about constellations that were worth like 10,000 satellites or so. At the same time, the reason why I launch a satellite is because you do a service. Like I'm involved in a company called Aurora Tech in Germany, which is doing wildfire detection. It's a flying infrared camera, basically, or a constellation of infrared cameras. And there's so many huge benefits that come out of these type of services that, for instance, if you monitor the world globally at least once or twice a day, there will be no surprise catastrophic fires anymore because you can detect them at the very early stage, and if you have firefighting capabilities, then you can extinguish them. I could go on forever. I promise you that every listener, viewer of this podcast is using throughout the day those space technologies without even noticing it much. Like, it's most normal thing to have a weather satellite image at the evening use before so you know if you need an umbrella the next day. But it's also like when you go to an ATM machine to withdraw cash, that the data packages are GPS or synchronized. When you are a woman who is going into a predictive cancer detection monitoring, basically, it's very likely that the software that is used for detecting cancer cells is the same that is used for an X-ray satellite in Germany in the late 80s. It's the same mathematical algorithms. So space is everywhere. It has become an integral part of our society's infrastructure already. But most of it is invisible. Like 90% of the space activities are a given. That the fuel injection in your car has been optimized by research we did in 0G at the International Space Station. That you have, data communication, that you can watch an NBA game in the US in near real time back in your home. This is a given, and then there is this 10%, maybe less, of this inspirational stuff of people living and working on the International Space Station. By the way, anybody of our viewers who is younger than 25 years has never lived in the world where all humans were on the surface of Earth at the same time.
Yeah, that's
because
a
the space station
powerful
is
idea,
permanently
in fact.
staffed.
And there are many such. Excellent. And the first time I discovered the term analog astronaut and this direction was this April, when the Mars simulation expedition was conducted in Armenia, in Armash. So before getting to talk about the Armash expedition, I want you to talk about what does this mean? What does Mars simulation expedition means? You talked a bit about it, but just how you started, how many such expeditions you have already and your team have already done.
We do those Mars analog simulations because we know you need to get out of the laboratory and need to get your hands dirty and accept that things are breaking. So we are dispatching crews of typically 6 analog astronauts as a crew for typically a month or so into a Mars-like region. We've been to the far region of Oman. We were in the north of Sahara in Morocco. We were in the Negev Desert in Israel, for instance, and now in Armenia with our 14th expedition. This means we have a small crew. We are still cheating a little bit because we still need a small support team also for safety reasons, like medical safety and so on, what we call the ground operation support team. We have a lot of Armenians in that team actually now. And then there is a mission support center in Vienna, Austria, which is the ground segment. That's the Earth, so to say. This involves people from, like in the previous mission, 25 nations. These are highly international, highly interdisciplinary projects. And why we do this is that we study the workflows and see where do things break, where do things not fit together. So every mistake we make here, we are grateful for because it's something we can correct before we go to Mars. Because the next, replacement part shop when you're on Mars is 380 million kilometers away. That's a very tough way to get the replacement part. And it goes even to the point that we had. I have personally experienced that as well, that we had several situations where we said, okay, if this would have happened on Mars, you're dead now. So I had several simulated deaths and so on. And I'm very grateful for this, because now I can work on the reason and avoid that in the actual mission. And thank God, in theory, you can still open the helmet and breathe some fresh air. On Mars, you cannot do that, obviously. So it's about making mistakes. It's about building, breaking, getting up again, and getting better. With the mantra of fail fast, fail cheap, have a steep learning curve. That's our mantra. So we're very good at breaking things and learning things.
Yeah. And you mentioned about risks that you are identifying through mistakes that you make, or through somehow understanding how many problems or issues can arise. So have you calculated what's the improvement rate from one expedition to another? So like in this one, we identified 50 things that would kill the crew, and then just 30...
We're dying less. So that's the good news. The devil is always in the details. So it means that it's not always the life-threatening situation. It's many times about efficiency. So we have developed a performance measuring algorithm where we say, has this mission been successful or not? And that includes, for instance, we look into does the original flight planning, the plan that tells who does what, when, where, with which resources, does this match to what we actually did? And the smaller the delta gets between the plan and the executed plan, the better we understand. And the better we understand the workflows and the mission itself. And this is definitely getting better.
So how close you are to your desired delta?
Well, at the end of the day, the delta should be zero. But that's unrealistic. So the amount of resource you need for this is increasing exponentially. I would say from the workflows point of view, like how you direct the mission, how you do the science in general, I think we're almost ready to go to Mars. I think even the spacesuit simulators we've been building and developing since more than 10 years ago, they're almost good to go if you add a pressurization layer to it. We don't need it for Earth because we can still work with ambient air on that. So that's the good news. The one thing, or the things we're a little bit more concerned is the one things we have not taken into account yet, the surprises. There will be surprises, there will be equipment breaking. If you're on Earth here on Mars, there will be things that will be breaking. And the question is, did I bring my 3D printer replace parts? Did I bring the option for producing a printed circuit board for electronics there? So what I'm most concerned about going to Mars from the risk point of view is not so much the exploding head situation or the exploding spacecraft or the fist fight with the little green man or so. It's the little water filter that was not perfectly designed, gets clogged, can only repair it from the outside, but you cannot do it because of any technical reason. And we're going to die in 2 weeks because when the filter gets clogged, we're going to die. And so it's those things that tell us we need to test an integrated, holistic approach as much as we can. Use it, everything we build, abuse it, overuse it.
Okay. And in terms of these analog expeditions, so you take care of the entire, if I can say so, value chain?
Life cycle.
Including life cycle. So including the equipment required for astronauts and all the way through. So can you talk about the components that are that create this expedition?
The biggest component is probably the paperwork. So we have, with a joking a little bit, we say that for every kilogram of simulation hardware we send to a mission, we need 10 kilograms of paper. So surprisingly, the first team that is active are the lawyers in our organization. It's about things like frequency licensing, customs operations, ethics commission approvals.
And that applies to Armenian expedition as well this year?
The same thing here, because no customs authority majority on this planet has a customs tax number for spacesuits. Yeah? And so you need some direct access to discuss with them how you do this. It's about logistics. Like for the Amash test site, our national support team from the Armenian Aerospace Agency, they had to build the road. They had to build little bridges just to access with the trucks, with the shipping containers from Europe to get there. There's a lot of logistics involved in this. Yeah. You need to find the best experiments possible. So you do an announcement of opportunity for the researchers. You have a peer review selection process for the experiments. You need to train the mission support people. You need to train the suit technicians. You need to have a medical team that knows how to get somebody out of the spacesuit, for instance. Then you need the crew itself. So it is all about people as well. You need the funding. Yeah, no bucks, no buck Rogers. Yeah. And then you're set. And the rest is with experience of all the manuals, the workflows, the decision-making process we have established in the previous expeditions, and we think we're getting better every time now. And so I think at the end of the day is the most important thing to instill this longing for things remote in the people that are involved. There is a famous quote from Antoine de Saint-Exupéry, the author of Le Petit Prince, The Little Prince. And he said, and this always rings the back of my head, if you want to build a ship, do not only teach the people how to put together the piece of wood, but make them long for the ocean. And that's exactly what we're doing. It's an ocean out there. We are at the shores of a cosmic ocean here on Earth, and we are the generations where we set sail for new worlds.
What do you think, which country or which government or organization will be behind the first Mars expedition, the real expedition?
It's a geopolitical question. I am very much convinced it will have to be an international consortium. No country on Earth, not Russia, not China, not the US, can do it alone or should do it alone. Also for some very pragmatic reasons, and that is, and we saw this with the International Space Station, for instance, international collaboration might slow down projects a little bit because there are more decision makers involved. But it also adds program stability. It's not if you have a new election, if you have a president or a new government that they say, wow, that's from the predecessor government, let's scrap it and do something else or so. But if you have international obligations, it's much more difficult to withdraw. And so I would say it will very likely involve some of the usual suspects of the big nations that are involved in space exploration, like China, like Russia, like the US, hopefully also Europe or so. But once that is done, this consortium is formed, and when the people will land on Mars, yes, they will have their country badges on the uniforms, but we go there as a species, and I think they will feel that.
Yeah, I fully agree, and I believe that that's the only way to Mars. So it should not be a sprint as to who will get there first, but rather it should be a collaboration in order to finally fulfill such a huge mission of not a lifetime, but like bigger than a lifetime. Lifetime on the scale of Earth.
It will be historic.
Yeah, it will be historical. Dr. Grömer, I would like to talk a bit more about Armenia now. We talked about the expedition this year you conducted, and I know that more are planned for the coming years or year. And what were your expectations, and what interesting discoveries your team found here, and what do you in general think about the industry here in Armenia? I know that we are just starting and we don't have now in the Free Armenia, Armenian Republic, we don't have these capabilities up until recently, but we had great professionals in Soviet time.
Yes, I'm well aware of that.
It will be great to hear about your opinion and your views.
So first of all, I must admit that Armenia was not very much on our radar for Mars simulations, because you would usually go to large deserts of the North Sahara, and Armenia thankfully has that, so it's more fruitful, of course. but we were making announcement, and several countries were competing. Also, Egypt was interested, for instance. And then I got a call from an Armenian staff member in the European Space Agency. He said, "Well, have you ever thought about going to Armenia?" Like, not really yet, yeah. And so we dove into this, and my team would look into satellite imagery, look into geological research that has been conducted. So it's all well documented, of course. And we said, well, that's not so uninteresting. And so we dispatched a reconnaissance team, a small group of people that are mission experienced, and were very much welcomed by the team of Heike Aslanian to look into several locations. We visited many places, and we saw there are indeed some locations that have something we call geosimilars. That means geological structures that have literally twins on Mars, like sedimentary structures, like fluvial structures. And we said, well, that's interesting. If we ignore the blue sky and ignore the bushes here and there and ignore some of the sheep over there, that could do the trick. Yeah. And then you go into negotiations with the host country, and there's a memorandum of understanding, and you have the support of local industry as well. And so we immediately from day one we felt very welcome here. And I mean, the Armenian, this is no secret, Armenian hospitality is legendary, and this was
it
not
applicable
just,
to
I actually there was
expedition as well?
There's one thing I started to fear about Armenia, because you can get everything in Armenia except for small portions when it comes to food.
Oh,
I think during the mission, I usually lose a little bit of weight. I think I gained like 3 kilograms throughout the mission. I was really having a hard time getting rid of this again. So, because if there's one thing we fear as analog astronauts, as a flight surgeon, that say you're too thick, you have to do more training. So that's one thing you have to work on as a country.
Yeah, we need to work on it as well.
Yeah, but smaller snacks, yeah. Now, seriously speaking,
if we want to be part of this Mars landing, we need to reconsider
I wonder
portions.
how people are still so in shape here when you walk on the street with all this magnificent food. What we also learned then, after we had signed the MOU and started the intense interaction of in the logistics of building the station, the regulatory environment, and so on. I was able to dive a little bit more into the innovation ecosystem of Armenia, and this was quite surprising to see two things. One is that there is a strong drive for innovation. I mean, the mechanism that you can form a company within half an hour in a one-stop shop in a single location in Yerevan is something I'm not used to as a European. It's much more a long, lengthy process or so, but here, zack, it goes, and there are many tax incentives. So really a culture of making it easy to do a company and to come up with innovation. And the specific thing about Armenia is it's not only because it's landlocked, but there is the countries around Armenia, not all of them are friendly, which means we have a situation similar to Israel, that when you do a product or a service development, and you might be able to sell it on the domestic market, but if it's something like space, there is not market for it. So you have to go global immediately. It goes from local to global. There's nothing in between. And this is a nature we also see in space activities in general, that once you have built a little satellite in the backyard of your garage, and the moment you launch with this service, you can be going global immediately by definition, because the satellite is going around the globe.
Because it's global.
So that's a parallel we see in other in Armenia, in other businesses as well. And the second thing was that there is a mindset that I really admire in a way when it comes to risk taking in Armenia. I have the feeling that the Soviet Union times, there were good things, there were not so good things, but a lot of the gung-ho attitude of let's just try it, and if we crash, we stand up and do it again or so. That's more American than European, I would say. And this is a very important attitude, that you are not deterred from being potentially failing at a point. You just do it. Yeah, it might not be the perfect product or so, but this can-go attitude in innovators in Armenia is great. And combined with a very well-connected expat community in Los Angeles, in Paris or so, this is a very powerful mix. So I think Armenia can be proud of that. There's a lot of potential in this. I think the challenge now is to streamline it and set priorities and see where the resources the government has or whatever the support mechanisms will be, in which direction should they be, what should be the prioritization. Armenia cannot do everything, yeah, but you can choose what are the niches. And I think space here is the privileged position because, as I said, going from local to global is something space activities allow by their very nature easily.
Yeah. And what do you think, what situation we will have in terms of development in 2-3 years here, in 5 years? Yeah. And what should we do as a nation, as a government maybe, or organizations that are in the space should do to accelerate this growth?
I think it's a little bit like building a pyramid, that you need a solid foundation, and there are already a few building blocks that are there already, like a very good educational system when it comes to engineering, into electronics, IT, and so on. And so secret Armenia is a IT stronghold. There is things like just yesterday I was in Engineering City in Yerevan here, which is a formidable program, and I admire their both already manufacturing facilities for small-scale production for PCBs, but then there are still construction sites where the buildings are just emerging. There's a huge potential there, and we just had a few talks of what can be done and how to connect to the international community. As I said, Armenia is not like to do everything by itself. So it's about finding the right partners for reaching out to research institution, companies, and this is already happening. Then there is National Instruments is in Armenia, stronghold, Microsoft, Emerson, and others. I think it needs even more of this because it also allows for an exchange of thoughts of personnel that students go to Germany for the master program, come back again. If they come back, that's important to create a welcoming back culture here as well, to move the brain drain to a brain gain. We see that's already happening to some extent. And then what I would recommend is going bold for a moonshot. That is devising a strategy where at the end of this process is something that is incredible sexy. Yeah? Something like saying, in 5 years, we want to see an Armenian astronaut on the International Space Station with an Axiom mission, for instance. That can be done. Yeah. And it's affordable.
So set very ambitious goals.
Very ambitious, yes. Not too low. Yeah. There's nothing worse than having a life goal and then reaching it before you die. Yeah? And so this is something where I think Armenia would, because it's not only about that one person that goes to the space station. It's this much larger community of people who are inspired, that are supporting such a mission. The teenager that is choosing an engineering career because he saw that lady, that man going into space and being ambassador for space activities. I think that's something where this moonshot would be a trigger for many things that are going beyond the immediate benefit.
Okay. And if you compare Armenia to more to countries with, but in terms of the size similar or just a bit bigger, how their ecosystems developed.
Yes.
So in this perspective, is there a specific country which ecosystem is can be like not replicated but used as a best practice? What do you think?
I would say so. The one country that immediately comes to mind is Israel. Israel is heavily investing in innovation because it wouldn't do good in investing so much in agriculture like we do in Austria. With all respect to the agricultural sector, of course, but Armenia does not have oil, significant portions. It's not there's any ores that can be deployed. So your natural resource are your brains. Yeah. And that says you have to go into the innovation sector, be hungry for export and international connections. And so what Israel did right, and that's the same thing we see here, is making it easy for startups. I think the one thing that Israel is also doing very good is attracting venture capital. And also from the tax perspective, make it attractive to invest. I think there are things moving in Armenia in this direction. I think there could be a little bit more done in that direction, and then create the hubs where you have cross fertilization. I think that's the one that is just in an embryonic stage now in Armenia, like with Engineering City, for instance, where the engineers of different companies, initiatives, and research teams meet in the cafeteria, and then new ideas are being produced when having a coffee together. I think this catalytic infrastructure, that's something where you could do the next step, maybe. Okay. But that's just my personal opinion.
Yeah, sure. That's very interesting. And you mentioned also the education component. But the thing is that we don't have programs that are directly linked to astrophysics or just preparing students for careers.
It's emerging. There is already a bachelor and a master program within the Engineering City for aerospace engineers. There are, of course, astronomy courses at university and astrophysics graduates there. There are great observatories in Armenia as well. I'm not sure if it's on the radar of every teenager that this can be a career. So I think it's also more of a recruitment question of that when a 17, 18-year-old teenager says, I'm now taking my decision on which career I'm going to pursue, that we have to be much more proactive and say, I haven't thought about doing your career in space. And for that, we benefit from role models of people like Hannah who are really ambitious, driven, energetic personalities. And if you see them on the street, you wouldn't imagine that such a person is doing these great things and also being the first analog astronaut from Armenia, for instance. And so I think the role model promulgation is something that needs to be worked on to feed into the already existing academic structures.
But I see now more teenagers who are interested in space rather than young people studying in STEM universities or taking STEM professions.
I think we have to be cognizant of we don't only need mechanical engineers, electrical engineers, and astrophysicists in space field. We need lawyers. We need graphical designers. We need language researchers who know how to create a narrative. We need filmmakers. We need people who are in the safety business. So there's almost no profession that is not needed. I remember even the Austrian Space Forum, we once had a priest with us for ethical questions. For instance, what do you do if somebody dies on Mars? How do you handle this? What would be an ethical way how to do this? Wow. Or what type of bodily modifications are still ethical to do to increase the chance of survival on Mars? And so you need ethical people with ethics science background. So I think the catching point does not necessarily only have to be the teenage years. It can also be postgraduate saying, well, you are a specialist in nutrition science and dietologist. We need people who design diets for the astronauts. Isn't that a sexy project?
Yeah. Mental health coaches and other
psychologists
and other emerging professions that are now there. And then you talked about making the profession more appealing to young people. So let's sum up our episode today with some advice for young people, young scientists who are already pursuing careers, and then teenagers who are thinking about going into aerospace majors. So what would be your advice, both in terms of academically and professionally, and inspiration and having this, calling and the feeling of mission inside?
Well, technically, of course, if you go into STEM fields, you have a big advantage when you go to space activities. What I can suggest to teenagers that are not really sure about which career path they will prefer is sit down, preferably with pen and paper, and sketch out a perfect working week in 20 years. Like how do I have meetings? Do I want to stay in the laboratory? Do I want to talk with people? Do I want to fill up an Excel sheet? Some people find that comforting as well, so whatever. And then you say, what profession does have that? And then you have like a lighthouse of a career pathway. And then comes the important part, that from now on, every decision you take, not just which studies you do, every micro decision, which book do I read, which movie do I watch, which summer school do I attend, with whom do I follow online as a podcaster or so. Every little decision you take should be towards this direction of the lighthouse, so to say. And I can tell you from a personal experience, once you take the decision of being focused on a career in a way, and you have the feeling of discovering something new, this has a magic of its own. It's just telling the world, I have found something new. It is incredibly powerful. It drives us as a society. It drives you personally. It's extremely rewarding. And as most of this is also civilian activities, you get to work with the brightest minds that are literally working on exploring the secrets of the universe. How cool of a job is that?
Yeah, exactly. And do get to meet many teenagers back in Austria and, talking to them about
it's
this.
a luxury I try to take, teenagers, but also school children, even kindergarten children, going into kindergarten as an astrophysicist and talk about the work you're doing is the royal discipline of science communication. And I can only recommend it to any scientist, go to kindergarten. If you're not able to explain what you're doing to a kindergarten child, you don't understand it yourself fully.
Okay. So I hope next time when you visit Armenia, I know that this is your 5th time actually in Armenia. So I hope that next time we can get 1 or 2 hours of your precious time and meet with some students, high school students.
My pleasure.
Who will, I think that it will be a huge source of inspiration and it'll benefit them a lot.
My pleasure.
Thank you very much, Dr. Grömer. This was very, very interesting, first for me, and then I'm sure for our audience as well. And thank you very much for the work you do. I'm sure that one day when this expedition successfully lands on Mars, there will be a movie and it will feature you.
Okay.
So
thank you very much for having me. It was a pleasure.
Yeah, and then Mars. I hope I will see that as well. And I hope all of us will see that expedition to come to life, and then we'll see the benefits of it, not just the expedition. And then, have a nice rest of the day. And then I hope very much that we will meet here again.
My pleasure. On to Mars.
Այսօր այսքանը այս մասնակցը արդեն հայերենով, շատ շնորհակալ եմ, որ դիտում եք մեզ, լսում եք մեզ։ Եթե դուք հավանում եք այն բովանդակությունը, որը ստեղծում ենք, անպայման YouTube-ում սեղմեք subscribe կոճակը եւ զանգակը, որպեսզի նոր էպիզոդները բաց չթողնեք։ Իսկ մենք կհանդիպենք հաջորդ շաբաթ։ Շնորհակալություն։